Logically, the question that arises is why are stacks used when they pose such a threat to security? The answer lies in the high-level object-oriented programming languages, where procedures or functions form the basis of every program.
A stack is used for storing the context of a function. For instance, if a function simply pushes all its local variables onto the stack when it enters and then pops those off when it's over, its entire context is cleaned up so that when the function calls another function, the called function can do the same with its context without the aid of the calling function's data. Now, the flow of control is determined by the function, which is resumed after the current one is done. The stack implements the high-level abstraction. Now, apart from this, the stack also serves to dynamically allocate local variables used in functions to pass parameters to functions and to return values from the function.
In fact, though several applications are written in C, programs written in C are particularly susceptible to buffer overflow attacks. And why is that? Direct pointer variations are permitted in C. Direct low-level memory access and the pointer arithmetic are provided by C without checking the bounds. Moreover, the standard C library provides unsafe functions such as get that write an unbounded amount of user's input into a fixed size buffer without any boundary checking.
Yeah, and to program buffer overflow exploits, you should be acquainted with the following aspects: stack and heap memory processes, how system calls work at the machine code level, knowledge of assembly and machine language, knowledge of C and Perl programming language, familiarity with compiling and debugging tools such as GDB exec system calls, how to guess some key parameters, just some of the things we need to think about.
And when you are equipped with these, you will be in a position to program code better. You also will be in a position to handle any buffer overflows seen during regular testing or usage. If there is an attack, you will be able to analyze and address the issue quickly, which we all want.
Exactly right. And you have the know-how now of handling buffer overflow vulnerabilities, which is, priceless. Now you must try to identify vulnerabilities and understand their severity. And we suggest you follow these 4 steps. These same steps are followed by an attacker to exploit any weaknesses. First, you should go through the same process to understand things better and address the vulnerabilities. Check whether the target application or program is vulnerable to buffer overflow or not. Buffer overflow typically occurs when the input entered exceeds the size of the buffer, right? It overflows. So test the target. You should work to inject something malicious into the program and see what happens. And if there are any potential buffer overflow vulnerabilities present in the program, then it displays an error when you enter a lengthy string exceeding the size of the buffer. Now you know whether a program contains a buffer overflow vulnerability or not. If it is vulnerable, then find the location of that vulnerability. Now you know that there is a vulnerability, and now you know that there's a location. We're getting closer.
Yes. So next, you try to write more data into the buffer than it can handle. This causes the buffer overflow, of course. You do this several times with input varying in type and size to understand the behavior of the vulnerability. It is worth taking the time. If you are a pen tester, you are testing the program in a test environment.
In assuming that you understand the behavior of the program, you know that when a buffer overflow occurs, it overwrites the memory. So now you try to overwrite the return address of a function with the address of the shell code. Try until you succeed. If you are successful, you got it. And you could attack the program or the application. Now you know what damage you can cause. It's kind of powerful, isn't it? With these inputs, you can attack a program or application and cause some damage. And you can prevent these attacks if you test for vulnerabilities.